And we are back with the Generals, our next team here, 3636. A team that has been making tremendous progress coming in from Oregon in the PNW, and can't wait to hear more about what's going on with this team and the robot that they have in the background, which we're very excited. We showed off some of this in our social media as well, too. So we got Charlie and Peter back in to speak more about the robot. Do you guys mind just introducing yourselves? Let us know what you do on the team.
Yeah, hi, I'm Charlie. I'm the co-captain and CAD lead of the team.
Yeah, and I'm Peter. I am also the other co-captain, and I'm fab lead.
You guys got a lot to show today, going through your CAD that you have for that. We'll dive into that. And of course, we got to talk about the robot in the background too, right? That's the big show piece to have as well. But why don't you start us off? We'll bring up your CAD. Talk to us about some of your progress you've been making, some of the subsystems going into it, and we'll break it down a little bit more. Your destination for FIRST content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Stryker Careers. If you are a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many FIRST alumni are coming to Stryker for their internship or career at careers.stryker.com. First Updates Now is supported by Kettering University. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental U.S. scan the QR code and complete the form by the date on screen and receive more information about Kettering.
All right, of course. So this is our CAD. It's looking fairly similar to how it did last time we were here, with one major addition over in the back here, which is this traversal climb subsystem that we're working on. And basically, what happened is we ended up getting done with the robot a lot sooner than expected, and so I threw this together over a couple days, and it's basically like a stretch goal for us. If we can, get the robot up to where we want it, then we might as well just start work on something to go for that traversal climb. But other than that, not much has changed. We've got our same old intake, conveyor mechanism, and the shooter. We did change a couple of things about the shooter after some more prototyping. There's now even more wheels. So we've got 3 4-inch Coulson wheels on the top, or on the bottom, sorry. Actually, I can just show you back here. But and we've got 4 of these 2.5-inch Coulsons on the top roller. So what we found was that having the 2.5-inch wheels on the top roller actually helped our accuracy quite a bit and consistency with the shots. And then increasing the number of wheels just made it a bit more consistent. If the ball was slightly off center in the conveyor mechanism, it was changing the effective compression that was on the ball. And so it was leading to some inaccuracies and inconsistencies. So we had more Coulson wheels, so we just figured to, just add more of them. Yeah, and that's about it for the major changes that we've made. But I can go more in depth about the traversal climb if you'd like.
Yeah, absolutely. When we had you guys on a couple of weeks ago, a lot of hype around, your CAD that you showed and your traversal climb concepts for us. So can't wait to talk more about how you've honed that in a bit more and looking to get that going.
Yeah. So in the end, what we decided on was actually something similar to, quite a bit of teams are doing it. The way I first saw it was the Lego climb, actually, the YouTube video of like someone prototyping it in Legos. But the way it works, right, is instead of the, I guess, more traditional traversal climb where you have, you have a pair of completely static hooks, and then you have another pair of hooks that can both extend and pivot. You've got one pair of hooks that can extend, which obviously we already have, or mid-climb, and then you have another pair of hooks that can pivot. And so it's kind of hard. I'm not very good at explaining it. It's kind of more easy to show visually, but like you can basically hand off between the bars. It works.
Yeah, and it reduces the complexity. So you don't have to have both a pivoting and an extending bar. You can separate them, which just reduces the complexity and makes it easier to to not have to do both at the same time.
Yeah.
Sure.
And so these pivots, we basically, most of the design process here was just how to make these pivots as strong as possible. So it's powered by 2 Neos, each of which is on a 125-to-1 max planetary, which is the biggest ratio you can get. And then additionally, it's got this 3-to-1 chain reduction for a total of 375-to-1. And so it's also on a round tube axle instead of like a traditional hex axle. And so that's just to increase the pivot strength so you're not bending a shaft. And the sprockets here are just bolted. Where's a good angle for this? They're just bolted directly into the tube itself, so you can run the axle dead. And then these shoulder bolts, or these like large bolts here, are basically just hard stops, so that we don't go too far and extend outside of our frame perimeter, or no, extend too far outside of our frame perimeter because there's the 16-inch limit. So yeah, that's about it for the climb. Oh, and then they're just there's just a bunch of sort of bracing between all of the structures that just helps keep it all from getting twisted around or bent or anything. Yeah.
Yeah, and it looks like a really solid design. So, did you end up prototyping this, or are you just kind of going for it?
Yeah, we are just kind of going for it at this point. Well, more or less, the thought process is, enough other teams have done enough prototyping with similar systems that we can more or less just, throw something together and, I'm sure it won't work on the first try, probably, but like we can have something that's, 1 or 2 revisions. Yeah, that's 90% of the way there. Even if we've done very little prototyping ourselves, just because we're borrowing from other teams' designs from this year and even from past years. Actually, a lot of this pivot design is inspired by like ARM systems from like 2019 and 2018.
Got it. Yeah, that's ultimately like the point of the Open Alliance, right? Is that teams willing to openly share within the season, and I think that's this is the drawing inspiration from other teams. Is it's going to make everybody better, which is kind of the goal.
Mm-hmm.
So let's just take a deeper look in the robot behind you. That's the jewel of the video here. So do you want to walk us through? Just kind of give us a walkthrough where you're at. It looks great, but show us around.
Yeah. So Peter, you want to start? Yeah. So I guess we can start with the intake. This is basically all final parts, all machined polycarb and everything. One thing that is not final is the retraction system. Right now we just have something just hooked up. So it does actually retract, and then we can get it to go back down. But we're going to be replacing the mini sim with a Neo 550.
Yeah, this right now it's powered by a mini sim on an ultra planet or a max planetary, because that's basically the first thing we could find in the shop today. But in the final version, the plan is to use a Neo 550 on an ultra planetary, which should be strong enough and much lighter and more compact.
Yeah, this intake is only like 8 pounds, so super
it's
easy.
Like 6 or 7, I'm not sure. It's like 7.
Yeah.
Oh, and then another thing on the intake that's not in the CAD, because I didn't want to like linear pattern 40 of these, is we have a bunch of spacers. These are just 1-inch spacers that we put in between our compliant wheels, and basically what we observed was after extended amount of driver practice, we were seeing the wheels kind of get moved side to side and kind of move out from the center, which we didn't really like. So we just 3D printed a huge quantity of spacers overnight, and then just put them on the shaft here.
Yeah. And then another thing is obviously our climbs. The TTV climbs are super nice. We These are obviously for low and mid, and we can just basically just bolt on our traversal climb if we do get that done. But it is all set up, and also this is the first year that we've actually done painted frame, which is something that's definitely new to us. It's just spray paint. It's not powder coated or anything too fancy, but I think it just makes the ball look so much better, just so much more clean and finished.
Hey, you are in good company with the spray paint. This is two robots we've had on tonight. Both of them look amazing, and both of them are spray paint. So to anybody, when you're watching this, your robots look great when they're in colored. You don't need to powder coat them. You don't need to anodize them. You just need someone with a steady hand, and you can make it look great. And because there's no bag, if you have to touch it up later on, just still touch it up.
Right over here, this is some of the stuff we used. It's just this paint and primer stuff, and so we put there's only like one coat of this on most of these pieces, and it still looks pretty great, even up close.
Yeah.
Well, it's not like anybody's looking at your robot with a microscope or anything either, right? Like, I mean, people might notice scratches, but any robot can get scratched, right? So
Oh, exactly. I mean, this front bar. I mean, it's the first point of contact, so it's already roughed up a bit, but I mean, you can't tell at all. And you can always just spray it all a little more, and it's fine.
Yeah.
One question I want to ask is one of the other teams Greg was alluding to is Team 95, and when they showed off their intake, it was a much more rigid intake, it looked like, than yours seems to be a little bit more flexible or compliant from a side to side. Have you done any sort of like impact testing or anything like that to see during a match if you might get hit or something?
Well, not quite on purpose, but our driver does have a tendency to ram into things.
Yeah, so I mean, if you ram right into the front of it, it just folds up and comes back down, so that's not an issue. And then from the side, I mean, we haven't done official testing, but I mean, you can push it around and stuff.
You can push it around, and actually what we found is that these, I don't know if you can see quite in here, but these polycarbonate fins here that are that help center the balls, they also pretty much go right up to the intake. And so when it gets hit, they almost act as like additional springs on this, which was not at all intended, but it just sort of worked out that way. The one thing I am worried about with this intake, and really the sort of the weak point of a polycarbonate intake is about right here, right? This, because this is pretty much the thinnest part here, right below this bearing. And so that's kind of the only place where if we get hit like right in the corner here, we could be in trouble. But the plan for that is we're going to bring backups of pretty much every single plate on this intake, just to be prepared.
How long do you think? So, like you're talking about backups, so you're going to bring a whole assembled intake with you, or just the individual parts?
Most likely just the individual parts.
Yeah, although we should have enough to, if we needed to, basically completely rebuild the intake. So
I think the only thing we wouldn't have is the compliant wheels right now.
Yeah.
But because we have so many of these on the robot already, we use pretty much every single one we have.
Yeah.
Cool. So we saw a video that Tyler brought up of some shooting out in the courtyard. How would you say your shooter's performing? Or is it up to your standards? Are you liking the performance so far?
Yeah, I've been really happy with how our shooters performed so far.
With 100, I think I'll have the exact video, but with 100% on both the bottom and the top, we can shoot it easily 30 feet in there, which not really that helpful, but fun to do. And then it means that we can just lower the power a bit, and then we can just shoot in the actual goal from reasonable distances and without hitting any ceilings. But it's been working really well since we switched to the 2.5-inch Coulsons on the top. That's also, I think, helped our consistency a little bit, and then just putting the wheels closer together, so we don't have that effective compression issues. It's been working really well for us.
And is your strategy still for most of your shots to happen like from right up against the goal, and then you just have the ability to shoot further away if you need to? Is that still what you're thinking?
Yeah, that's still what we're thinking right now. We've been tuning the shooter for the past few days, including replacing the wheels and all that. And right now we we've gotten it to, what would you say, 80 to 90% accuracy in from the fender shot, and that's before like bounce out, which is definitely going to be an issue, and I think that could lower the accuracy a bit still. But I'm pretty happy with how accurate it is from the fender, and having having so much power from these 1-to-1 Falcons. A lot of people have said, oh, those are kind of overpowered for just shooting from the fender. But what it means is we still have a lot of headroom if we want to try and go for those longer shots, which we've tried. Accuracy on those has been still a little iffy. We've managed to hit 2 in a row a couple times, but not consistently.
And bounce out might be more of an issue in that scenario. Just more energy.
If I can ask, in the video I'm gonna pull up here where you have a close fender shot, right? You shoot two very close to each other, and this could be like a depth perception thing on my end, but it looks like the red and blue ball might almost collide in midair or something like that. Have you had anything like that happen, or are they spaced out enough where you don't really need to worry about that?
So this is pretty initial testing.
Sure.
We will in the end final probably have it so it will automatically space it out. To allow for the flywheel, or to allow for the wheels to spin back up if that's necessary, and then so they don't bounce out into each other. So even if it is an issue right now, which it really isn't, it will definitely be a non-issue during actual competitions.
I do want to hop into your climb in just a moment, but I do want to grab a question from chat that came in regards to your intake. Olazola asking, how are you dealing with up and down limits of a motored power deployment on your robot? You can see when you're kind of running up and down, like it looked like it was a little bit of torsion to it potentially, or maybe if it just was not even coming down.
No, it definitely was, and that's so. The first part of that is a bit of a mechanical fix, actually. Right now, this intake, because like I said, we kind of just hacked this together, like an hour ago. It's not a super finished product, and ideally, in the final version, we'd have a longer shaft here and have 2 ropes going down to the corners, just so that we're not putting that much bending load on the shaft. And we're not going to use churro for this. We use like a real hex shaft. But the other part of that, is having some kind of mechanical limit, or even like a limit switch. And that is, I'm not, as a non-programmer, I'm not quite sure how qualified I am to talk about that.
But you're aware of it, right? Like you're aware of the issue. You're looking to fix it.
Something that exists that could be done. So I think that would be the goal, is to have some kind of software limit, just making sure we don't extend too far and start twisting that shaft or bending that shaft.
Yeah, I'd say that one of the biggest challenges with the cable deployment and retraction is actually going too far when you're putting it down, because if you continue to go too far, it's just going to continue to spool. So you actually be going back up. And I've seen, in some cases, teams who do that type of mechanism, what ends up happening is you lose where you are in software, right? So like you're pushing down, but you're actually going up. And so it kind of puts a little bit of a pressure on the driver to kind of think which way is the cable spooled. So if there's talking to your programmers or electronics, thinking about, some, maybe even a brake beam sensor or something down on the intake itself, I think that's going to buy you a little bit of flexibility, so your operator or driver don't have to think so much about it. But it's all solvable problems. And with a beautiful robot like this in week 5, you have plenty of time to work through stuff like that before your first event.
Well, yeah, thank you. And that's definitely the plan, is just, right now, this robot is done enough to where we can sort of hand it off to the drivers and the programmers for the next couple weeks and, let them do their thing. And then, meanwhile, we're going to be in here figuring out the traversal. And then ideally, right, that all comes together sometime in the next few weeks, and we get a working robot with, with some cool software stuff and the traversal climb.
Well, Makilia in chat, hopefully that answers your question about the drive team. But hey, guys, let's hop into, as we start to wrap up, your traversal climb concept and ideas. And your climber is on your robot, or at least part of your climber is on your robot. So talk to us more about what's going on with that.
As But yeah, this is our the mid climb, and it's basic. I mean, it's done. It could be. We've tested it and it's been working fine. And it is, and because the traversal climb is basically just a bolt-on thing where we don't really need to modify anything with the current climber or anything. We can just kind of put it on, so it's not strictly necessary for everything to work. So I would say that's a good update there. Yeah.
How does your so you're using the ThriftyBot climb, and how do you hold yourself on the bar at the end of the match? So what's your plan for making sure the robot doesn't drift down?
Falcon 500 brake mode currently. So we've got the climb. Each climber arm is powered by a Falcon 500 in a 12-to-1 max planetary gearbox. And what we've determined from that is we've done quite a bit of testing, and we've seen that it takes, what would you say, like well over a minute for the robot to start slipping down from the bar. So
yeah, even if you don't get all the way to get pulled all the way up for the 5 seconds that's necessary till the end of the match, or until they count the climb, we will be perfectly fine.
Yeah, so we've got more than enough torque to just keep us in the air.
Awesome. Yeah, well, that's a great plan. I mean, that's one of the nice things about brushless is that brake mode is definitely a thing. But something teams who are doing their climb really want to consider how to stay up, because I think that we're going kind of backwards in terms of rules, right? Because in 2020 it was an instantaneous end of match, or you balanced or you climbed, and this is the more like 5 seconds after the match ends, everything come to rest rules. So I think that teams who might have drifted down in 2020, need to figure out how they're going to hold themselves up this year. So it's good that you've tested that.
And actually, if one thing we're thinking about for the traversal is potentially changing the gear ratio on the mid climbers to 9-to-1, just to speed up the whole process. Because our main goal with the traversal is to get it to under 20 seconds by our first event. And so just, for it to be really worth it in terms of points. Mm-hmm. And so changing these climbers to 9-to-1 could definitely speed up a little bit, but we're not confirmed on whether that's going to be quite enough torque to hold the robot up as long as necessary, but ideally we'll do some testing on that in the next few weeks.
Yeah, that's what nice thing about getting bot done this early is you have time to test things. It's not all thrown together last minute, mm-hmm. and then you just have to hope it works.
Yeah. We've been there before.
But correct me if I'm wrong, but if you have your traversal on there, those hooks that rotate, you can leave them on in your last traverse, and those don't extend, right? So that kind of acts as your alternative brake, right?
Mm-hmm.
If we have time to get.
If we have time to engage those as well.
Because getting to the last climb, it would be with these extended ones. So it's not as necessary to get the traversal pivoting hooks up there. But if we do, then
then that's its own sort of mechanical stock. You can't. Well, and actually, no, that's we actually don't even need that, because of the robot height limit rules, right? If we're on the traversal bar with our hooks, we could extend all the way and still not be touching the ground.
Well, 3636 Generals, we really look forward to seeing your continued progress for it. You guys play week 2 in P&W Wilsonville event, so looking forward to sub 20-second traversal climb. You heard it here. I can't wait to see it come out. I think you guys are going to do it. You guys have such great progress so far, so I can't wait to see what happens. But good luck to you guys the rest of the way, and we can't wait to check in with your team during the season. Thanks a lot for taking the time.
Yeah, thank you. I really appreciate it. And thanks to all the other Open Alliance teams who've helped us out and just, gotten us this far throughout the season. So, thank you.
Thanks to Kettering University for their support of this video. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental US, scan the QR code and complete the form by the date on screen and receive more information about Kettering. Thanks to Stryker Careers for their support in this video. First alumni and mentors are making Stryker a top priority for their internships and careers. That's because Stryker knows that those in FIRST are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/FirstUpdatesNow. Join our Discord at discord.gg/FirstUpdatesNow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.